Well, let's take a few minutes to look at some open-ended synthesis problems. And these are ones where we don't present you with a starting material, we just give you a target. And we provide a few rules of where you can get your starting materials. For instance, these rules might be that you can get carbon, or your carbon sources can be benzene or any alcohol where R is between 1 and 5 carbons. So you can start with alcohols that have between 1 and 5 carbons, no other functional groups, and you can use benzene as a carbon source. So these rules mean that anytime you add carbons to your molecule, you have to get them from one of these approved sources. And that's just to prevent somebody from saying, well, I went to the chemical store and I bought this molecule and now I've made it, I've got it. So this means if you want to use, say, phenol, you've got to make it from benzene. If you want this Grignard, you've got to make it from a 4-carbon alcohol. If you want some 10-carbon ketone, you've got to make that from a couple of 5-carbon alcohols. Let me erase these, and we'll think about how to do the retrosynthetic analysis. This is very important that you address these in a stepwise fashion. You can't just start from the beginning, well, because right now we don't know where the beginning is. What we have to recognize is that there are several pieces here, and we could look at this piece and say, well, that could have come from a 5-carbon alcohol, and I know that I can make this bond via a Grignard reaction followed by oxidation of the alcohol. So that is a possibility. I could also make this bond the same way. So at this point in the semester, whenever we see a carbonyl, we should recognize that that could have been an alcohol in its previous life or the previous step. And an alcohol, of course, can come from a Grignard. So carbonyls are equivalent to alcohols now. Alcohols can be produced via Grignards. You should be thinking about these synthetic steps, generic synthetic steps that can be used to help break down the molecule. Now, you'll notice that this dashed line here, if I choose to make this bond, I have 5 carbons on the left side of that line, and I believe I have 5 carbons on the right side of that line. So that line might be the best way to go, given that I can start with just 2 pieces of carbon. I don't have to do more synthesis to get them. And I'm going to draw all this in a retrosynthetic fashion, and then we'll go backwards. Then we'll go back and draw it in a forward fashion. And the retrosynthesis doesn't have to show every single step, but I'm going to do my best to show that to you to help us learn how to do this. So this could come from the alcohol. And since we're dealing with alcohols, I think this one should be protected until the very last step, because we don't want this alcohol to react similarly to maybe that alcohol in the middle. So I'm going to protect that alcohol as soon as I make it, and then I'm going to deal with this secondary alcohol in the middle. I can make this secondary alcohol, again, looking at this line, or this CC bond, as one that could have been made from a Grignard. So now I can make this piece into a aldehyde, or a carbonyl species, and I can make this piece from a Grignard, and that's how I will make this. So let me just draw that. And I don't have to think about this, I just need to draw it. Once I've established this, I'm going to draw my Grignard. And of course, I need to have that alcohol protected if I'm going to have a Grignard reagent present. I'm going to make sure that I count carbons, 1, 2, 3, 4. It's very easy to add or subtract a carbon by mistake when you're making this Grignard. And then I'm going to make the compound in green here. And really all I have to do is put another CO bond here, remove this H, and I have an aldehyde. So these two species mixed together, followed up with acid workup, give us this alcohol. Now the question becomes making these from the legal starting materials, which are going to be alcohols of up to 5 carbons. Both of these have 5 carbons, so they can come directly from an alcohol. The carbonyl species is one step away from an alcohol, so that's easy to show. PCC will get that one done for me. The next question is, how do I make this Grignard? Well, I know how to make a Grignard. I just need to start with the alkyl bromide, so let's do that. And the next question really is, I have two functional groups present on this alkyl bromide. There's only a couple of reactions that we've learned, including from first semester chemistry, that will put two functional groups on. And also, if we think about this, if I don't protect that, I have this alcohol. So this is starting to look a little closer to something that I might have dealt with last semester. I have a bromine on one side, I've got an OH on the other, or I can protect the OH, but it's the same thing. I'm going to proceed with the OH protected, I think, until I've actually made it. But that bromine can be added to the outside of the chain if I have that alkene, right? I can use HBr and peroxides to put the bromine in the anti-Markovnikov position. And this alkene could come from a leaving group on the secondary position. So what if I had a leaving group here? Let's deprotect this, or at least, again, we're still working backwards here. This molecule we learned how to make in first semester organic chemistry. This is the Br2 and H2O addition to an alkene. I honestly can't remember the name, but that's less important than being able to draw it. So if I have an alkene between the Br and the OH, I can add Br2 and OH, H2O, and that will allow me to put the OH on the more substituted carbon. I still haven't followed the rules because this needs to come from an alcohol, but I could put my alcohol in that tertiary side. I could do an elimination to form the alkene, and then I could add everything. So I think I have starting material here, and I've got starting material here. Those are my sources of carbon. Everything else is like an inorganic reagent, meaning it's Br2 or magnesium, or it's a base that doesn't add carbon, it's just used to do an elimination. And that's really all I have to do right here. So now I need to put it in the forward direction. And to do that, if I had a bigger screen, I would just write it next to all of this. Another way you could do it would be to erase all of these double-headed arrows. Let's see if I can do that here carefully. And then just put single-headed arrows going the opposite direction and add the appropriate reagents. I'm going to erase this piece because I don't need that distracting me. So let's erase that. And of course, you might have this ability to do it on your own screen, or you might just grab a separate piece of paper. I'm going to do it this way for our purposes. So if I want to eliminate that, I could do an E1 elimination, H2SO4, and heat. Alternatively, I could tosylate that and do an E2 with strong base like ethoxide. Then I can add Br2 and H2O to produce this bifunctional compound. Then I can protect the alcohol because I know that I'm going to eventually make a Grignard. I don't want this alcohol to react with that Grignard. Then I need to eliminate the bromine. And I need to eliminate, well, that's really the only way it could go, right? There's only one. This has alpha or beta hydrogens here. There are no beta hydrogens there. So if I'm going to eliminate this, it's only going to go in one direction. I'm still going to use the large base to help prevent any SN2 competition. And then I can add the bromine to the outside of that carbon, HBr peroxides. And then I need to add magnesium. And if you want to write ether here too, that's fine. And then I need to make my aldehyde so this magnesium or this Grignard can react. So of course the aldehyde comes from the alcohol. That's pretty simple, PCC. And then I'm going to mix these two together. So the first step would be just to mix these. Let me try to write that a little more clearly. And then the second step, of course, is H3O plus workup. That gets me to the secondary alcohol, of course, because I've reacted an aldehyde with a Grignard, I get to a secondary alcohol. And two steps actually. The first one would be oxidation of that secondary alcohol to make the ketone. Second step would be tetrabutyl ammonium fluoride to remove the TMS group and show or expose my tertiary alcohol. So that would be one possible synthesis of this molecule. There are others that we could do too. I could spend many minutes making several videos on this same molecule, but I'm going to move on to another target now. But if you think that you found another synthetic pathway, I'd be happy to talk about that with you in person. All right, let's look at this problem, and I'm going to have the same rules as before. I'm not going to rewrite them here. They are on the first slide of this video. We can use benzene and alcohols that have up to 5 carbons, monoalcohols, so no other functional group present. This means that my attention is drawn to this bond to benzene, because I know I can start with benzene. I can't start with anything that benzene has a chain on it. So I'm going to have to make that bond at some point. I'm also drawn to the lack of functional groups in this molecule, which means we've either removed the functional group, somehow gotten rid of the bromine, somehow gotten rid of the alcohol, or the carbonyl that we're left with, or the alkene. We know how to reduce alkenes to alkanes. That could be a result here. We know how to get rid of carbonyls altogether via the Clemmensen reduction. Or you could reduce the carbonyl to an alcohol, do an E1 elimination, and reduce the alkene. So we know how to remove the functional group altogether. So that's not really going to be a problem. I could put my final functional group anywhere I wanted to. So let me look at this process here. And I'm going to again draw retrosynthetic analysis. If I want to make that carbon-carbon bond to benzene, what if I had phenyl Grignard? And then I would need, let's see here, this piece needs to have an electrophilic site at this carbon, third from the left. And we know the only electrophile we know that reacts with Grignards is a ketone, or aldehyde, or ester. So since that's in the middle of the chain, let's make it a ketone. So now my job is to make this phenyl Grignard, and that is pretty straightforward. We just did that something similar to that on the previous question. I can use bromobenzene reacting with magnesium, and I can make bromobenzene from benzene. So there I have one of my starting materials. Let's make this red molecule then. How do I make that? In fact, I'm going to switch to green because I don't like red. Let's try purple. How do I make this? Well, we know how to make bonds next to carbonyls because, as I said, treat the carbonyl just like it was an alcohol, except that we oxidized it. So what if I oxidize this alcohol to get to my carbonyl? And first I should establish that I have to make this. I can't just buy the alcohol. 1, 2, 3, 4, 5, 6, 7. So it's 7 carbons. I can only start with 5. So I need to at least add a 2-carbon piece to this compound. And so we can look a little closer here. Either of these bonds would be totally fine to create in order to make this 7-carbon piece. I don't care which one you use. It doesn't really matter. Let's add the ethyl. So I need ethyl Grignard. And I need, this time I'll switch back to, let's use green here. This piece should be a carbonyl species. Nothing to think about, just redraw the structure, turning your alcohol into a carbonyl. Now those mix together, and I can get to the alcohol. How do I get to my Grignard? Well, same pathway. You're going to get really tired of making Grignards from alcohols. So long as I can buy ethanol, I know how to turn that into ethyl bromide. I know how to turn that into ethyl Grignard. And let's look at the last piece. So now I have 2 starting materials. This one is just 1 step away from an alcohol. And 1 more carbon there. So here's 1 starting material. Here's another starting material. And here's another starting material. So I can mix all of these, or I can create all of these and follow this pathway and make it to my product. So let's look at the last thing we want to consider is when I mix these two together. Let's draw that product out and see where that takes us. Of course, that makes a tertiary alcohol. We add a ketone to a Grignard, we get a tertiary alcohol. I can eliminate that alcohol to make some alkene, and it doesn't really matter where that double bond goes because I'm going to react that with H2 and palladium and it goes away. So I don't care where that double bond shows up. You could even make a ketone if possible, not on the tertiary alcohol here, but in other examples we could have made a ketone and remove that via the Clemmensen. So I'm going to go ahead again and erase all of these large retrosynthetic arrows, and you can maybe get a clean sheet of paper and follow along when I go through the forward pathway. So I know how to take this alcohol to a bromine. I know how to react the bromine. Again, I already had magnesium, so I can make the magnesium bromide right there. So that gives me my ethyl Grignard. I can make this aldehyde via PCC. So now I'm going to react these two together. First step is going to be to mix the Grignard and the aldehyde. And the second step is, of course, acid workup. And then that alcohol needs to be turned into the ketone, so I'm going to use PCC to do that. And then I'm going to go over here and make my phenyl Grignard. How do I put a bromine on a benzene ring? That's just Br2, FeBr3. So hopefully you'll see that we're combining lots of different chapters worth of information, including anything and everything from the first semester. Reacting bromobenzene with magnesium gives me the phenyl Grignard. And then I already have my arrow, so I'm going to use this, I'm going to cross off that one just to keep blue arrows together. I'm going to mix the phenyl Grignard and the 7-carbon ketone together. I'm going to add H3O plus to protonate this H here. And then I'm going to eliminate that OH via H2SO4 and heat. And I'm just going to write E1 here to remind myself I'm doing a dehydration. And then I just have to reduce that alkene with hydrogen and palladium, and I get to my product. And so I hope you see that this alkene might have formed between these carbons, and that still would have been reduced. It's possible that we decided to make this bond in addition to this bond here, so we might have ended up with an alcohol right on this carbon. We could have eliminated that and reduced it, no problem. So this molecule probably has more than 2 or 3 synthetic pathways that would allow you to make this molecule. So if yours is slightly different, feel free to come talk to me about it. I'd be happy to discuss this in person with you. Just remember the rules. So some students might say, well, I want to use this thing, this acid chloride for some reason. I wanted to put a 5-carbon chain on my benzene. Now, we will learn how to make acid chlorides in the future, but right now we don't know how to do that. So unless you show me how to make it, and if you read your textbook, you would show me this. And I have no problem if you read ahead. It's actually just a 2-step sequence from a primary alcohol. So certainly you could make acid chlorides, but you need to show me how to do that from the 5-carbon alcohol, or however many carbons you want. You can't just buy that. So those, make sure you're following the rules. Here is the final example from this video. This has a functional group present, and of course this is a ketone. Whenever you see a ketone, I want you to think, I can make that from a secondary alcohol. So maybe that is our final step, given that we don't have a lot of other ways of making ketones. This is probably our final step. So I'm just going to draw that before I even start thinking of other bonds that I might be able to make. And now that we have a secondary alcohol, there are actually 2 options that we could do. We could make either of those carbon-carbon bonds as a Grignard reaction. So I think that I'm going to make this one. Actually, I think I have to make that one, right? Because that's a 5-carbon chain right there. Otherwise, I'd have to add some carbons somewhere. So let's make our disconnection at the right side of this alcohol. Let me get back to my retrosynthetic arrow. So, of course, the phenyl side is going to have the carbonyl, as with all retrosynthetic Grignard. And then I'm going to have, let's use green now to keep that going. I'm going to have that species. And I can make that Grignard, of course, from the bromide. And I can make the bromide from the 5-carbon alcohol. So there's one of my starting materials. Let's look at the other one. So I have to make this bond now, somehow. This might require 2 steps. Add addition of carbon twice, maybe 1 carbon group and then 1 carbon group, or maybe we can add both of those. I think we could actually add 2 carbons at the same time. So let's try that and see where it takes us. And to get to the aldehyde, of course, I can oxidize, just like the thought was at the beginning of this synthesis. Anytime I have an aldehyde, that's the same as saying I've just oxidized a primary alcohol. So let's think about that. I could make a primary alcohol in a couple ways. I'm going to try this way, and then we'll look at, I'm going to draw this in red over here to remind myself that I think there are a couple ways we could make this primary alcohol. So let's look at the blue pathway first. What I'm going to do is assume that I had the alkene. I know how to put alcohols on the end of alkene. So if I have this alkene, I can make the alcohol, I can make the aldehyde. How do I make that alkene? That alkene can come from elimination of this compound. I know how to put bromine on benzylic positions. So if I have ethyl benzene, I can put a bromine there, and then I can eliminate it to make, this is called styrene. And I can take styrene and put the alcohol on the end of it. And I can, of course, make ethyl benzene from benzene and ethyl chloride. Benzene is now one of my starting materials, and I can make ethyl chloride from ethanol, no problem. And that would be a starting material. So that's one pathway. Let's think about another way to make this alcohol, with the observation that that is a carbon-carbon bond next to an alcohol. And if I use that piece as my Grignard, and I'll use the red piece, this is just a CO double bond with 2 H's on it. So don't forget about formaldehyde. This can be a very useful carbonyl species if you just need to add 1 carbon to a chain, which is what I'm doing here with this benzyl Grignard and formaldehyde. And of course, I can make formaldehyde from methanol. Methanol is a 1-carbon alcohol. That follows the rules. I can make phenyl Grignard. Let's go back to purple here. I can make phenyl Grignard from benzyl bromide. I can make benzyl bromide from, again, alkylation of the benzylic position, methylbenzene. And I can make methylbenzene from benzene and methyl chloride and aluminum trichloride. And I can make methyl chloride, again, from methanol. So this would be a starting material, benzene would be a starting material, and methanol would be a starting material here. And so at the risk of making this very sloppy, I'm going to pause the video, erase all of my arrows, and then I'm going to draw the forward pathway. So you can do the same thing while, well, you can pause the video and do the same thing. I'll be right back. Okay, since I've identified all of my starting materials by circling them, I can find a pathway to take now. This was a starting material too. So let's go from the left side here. I can take methanol, oxidize that using PCC to make formaldehyde. I can take methanol, turn that into methyl chloride via SOCl2 and pyridine. Then I can react benzene with aluminum trichloride to make methylbenzene. NBS, I think we'll need that again. NBS will make this benzylic bromide, and magnesium in ether will make the Grignard. I've got formaldehyde already. I can mix them together for step 1. Step 2, of course, acid workup to protonate the OH, and now I have this alcohol. I can make that alcohol a different way using a different pathway, and let's use some the purple down here to do that. So I can make the, from ethanol, I can make the ethyl chloride, SOCl2 and pyridine. The ethyl chloride plus benzene in the presence of AlCl3 will give me ethyl benzene. I can brominate on the benzylic position again with NBS. I can eliminate. I'm probably going to use a large base here because there is only one way to eliminate. I want to prevent any SN2 from competing if I can. Then I can put the water, add water across the double bond in an anti-Markovnikov fashion, BH3THF, followed by H2O2 NaOH. I can create, so now that's just another way to create that alcohol. You can do either one, it doesn't matter. So now I can take that alcohol with PCC and create the desired aldehyde. And then I can go over to this green reagent here. I can buy 1-pentanol. I can turn that into pentyl bromide with PBr3. I can react that with magnesium. I already have that there. Then I can mix these two together and follow that up with H3O plus to make the secondary alcohol here. And finally, I can react that with PCC to get to my product. So here's another example of an open-ended synthesis problem.